That was a close one.
Not half. Hope he doesn't got the pub. Come on, let's see if anybody's hurt.
All right, Ma. That'll be the wardens.
Anybody hurt?
No, don't think so.
You can't put the light on. There's a flaming great hole where the wall was.
Are you all right, fella? Can you get a cup of tea or something?
As a matter of fact, I just made some. I'll go and get the cups.
Well, that seems to have gone off all right. Made enough mess with it, too. Lucky neither of you two got hurt.
Who's going to clean up all this soot? That's what I want to know.
Don't you think it'd be far more comfortable if you came round to the rest end with me, Mother?
No, I'm going to stay just where I am.
You can't beat the old ones.
Well, we better take a look round at the rest of the house, and if everything's okay, we won't trouble you again till the morning. Well, you certainly were lucky with the bomb going off as close as this.
You don't think it could possibly be a DA, do you?
What, with all this damage?
Well, that was a pity. But it's very easy to make mistakes in bomb reconnaissance. And although you might not have made that particular one, there are plenty of other ways in which appearances can be very deceptive. Here, for instance, a bomb has demolished 4 lock-up garages. But has it exploded? Before you make up your mind, take a look at another case. This is a bomb which definitely has exploded. You'll see plenty of evidence of blast, and a point of interest is that the outer course has been sucked outwards. There are many other traces of blast and splinter damage, both on this house and on the one next door. And all this caused by the explosion in the garden of one of the smallest of German HE bombs. Let's go back to the first bomb. You'll notice that there's no trace of splinter damage at all on the house behind. Nor is there any trace of blast, the window glass being still intact. On the other side, too, there's no trace of blast or splinter damage, and that drain pipe is not even dislodged. See this crack? Looks very much as if it were due to earth movement. Then the middle of the debris looks as if a heavy weight had pushed down through the concrete, not as if an explosion had lifted it. In fact, in spite of the amount of damage, all clues point to the presence of a big unexploded bomb. So you see, it's essential that all branches of the armed forces, civil defense personnel and police have a sound working knowledge of the different types of bombs which may be dropped, the damage they're likely to do, and the signs which show whether they've exploded or whether they have simply buried themselves in the earth. Only in this way can accurate reconnaissance be made. Here's a range of practically every size and type of German high-explosive bomb. The rail against which they're standing is 4 feet from the ground. There are 2 main types, the more common of which is the thin-cased SC bomb. This has a high blast effect and what we call good fragmentation. That is to say, the case of the bomb breaks into quite small fragments which are projected through the air at very high velocity. To achieve this, the SC type of bomb is designed with a blunt nose and little or no streamlining. They rely for their truth of flight on the tail fin. Therefore, they can't be aimed as accurately as the better proportioned armor-piercing bombs we'll show you later. The SC bomb is used primarily for the destruction of property over wide areas, as compared with the armor-piercing type, which is used against specific targets of small area. It's this type also which is the chief anti-personnel bomb. The general construction consists of a steel tube body with a nose and a tail welded to it. The case has a thickness varying from 3/16 to ½ an inch. The nose is rather thicker than the rest of the bomb and has a solid piece of metal in the tip. The second type of bomb is the armor-piercing, or SD type. These are intended for targets where deep penetration is required before the bomb detonates. This calls for a shell thick enough and tough enough to resist distortion when piercing steel plating, as in the case of battleships. There can be no welding, and the case is a single steel casting. Typical targets for SD bombs, in addition to armoured ships, are electricity power stations, waterworks, large factories, and reinforced steel and concrete buildings of all descriptions. You'll notice that the armour-piercing bomb is much better streamlined than the SC type. This makes for greater accuracy on targets which present a small surface area. Armour-piercing bombs have thicknesses varying from 3/8 to 1½ inches, and there's a mass of solid metal in the nose. Some idea of the thickness of the case of the armour-piercing bomb may be gained from this diagram, in which the proportion of the weight of explosive to the weight of metal is shown. See the strong contrast between this and the proportion of the weight of explosive to metal in this one. Hence the greater devastating effect of the SC bomb. Now let's deal with these chaps in detail. The weight of all German bombs is given in kilograms. A kilogram is a little over 2 pounds, so if you double the figure, it'll give you a rough idea of the weight in pounds. The smallest German bomb in regular use is the 50 kilo. They're all roughly 2'6" long and 8 inches in diameter. They carry a sheet steel tail, which adds another foot to the length of the bomb when it's in the air. The difference between these three is solely in the shape of the filler cap at the tail end. When they're in the plane, they're suspended by a ring bolt, either horizontally or vertically. This is the position of the horizontal ring bolt, and the fuse goes in here. Next we have the 250 kilo SC bomb with a diameter of 14½ inches. Its length is about 4 feet, and the tail brings this up to 5'8" inches. This fellow causes a great deal of damage for its size, and what's more, remember, if it's a 250, it's very likely to have a delay action or anti-handling fuse. So you'll be well advised to treat any suspected 250 UXB with particular respect. This one has a dome top screwed on here. This one has a conical top and only one fuse pocket. But it's quite usual with the 250 kilo size to find 2 fuse pockets, as you see here. 1, 2. The 500 kilo has a diameter of 18½ inches, with a length of some 4'6". The tail fin brings this up to 6'9" inches. Like the 250, it may either have 1 or 2 fuse pockets. All these 3 sizes of SC bomb have sheet steel fins painted dark green, sometimes with yellow markings. You may occasionally find parts of these on the surface, but in the case of a UXB, it's more usual to find the fins or parts of them in the hole of entry, a few feet away from the bomb. The fin is held to the bomb by quite small rivets through these holes, and that's why it breaks away so easily. It's worth remembering the approximate sizes of these fins. The 50 kilo bomb has a 5½ inch fin. The 250 kilo a 10 inch fin. And the 500 kilo a 12 inch one. He's a big blighter, isn't he? Well, what about these chaps? But the largest of them has only 1 fuse pocket in spite of all that. It's christened Satan and weighs 1,800 kilos. The 1,700 kilo is a rare bomb. It was thought at first to be SC, but it's now definitely established as the armour-piercing type. The 1,000 kilo has been christened Herman. He's built that way. One thing these big fellows, SC or SD, have in common is the Cambridge blue colour of body and tail fin. Another thing, except for Satan, the tail fins are of a light magnesium alloy, so any piece of pale blue light alloy, however small, found near the bomb crater means a UXB of 1,000 kilos or more. This is part of the tail drum. The fin has broken off here. This is part of the cone, showing part of the fin and the tail drum. This is the lower part of the cone, where it's attached to the bomb. Probably the pieces you find will be very much smaller than these. Satan's tail fin is of sheet steel and of similar construction to the tail fins of the smaller SC bombs. These projections mark the position of what is known as the Kopf ring. This is a retarding ring fitted round the nose of these big SCs to reduce their penetration on land or water. The Kopf ring usually breaks up into smallish pieces when the bomb strikes. Unlike the light alloy fin pieces, it is of heavy steel, and you can spot it by its triangular section. A piece found in or near the apparent crater means a 1,000 kilo or larger UXB. The 1,000 kilo Hermann has a steel carrying band to which is screwed a suspension eye-bolt. Sometimes the eye-bolt is replaced by a carrying lug. The carrying band may become detached and be found twisted and distorted in or near the apparent crater, a good indication of a Hermann in the neighborhood. The lug may be torn off and found separately. The diameter of a 1,000 kilo bomb is 24 inches, and of the other two, 26 inches. With the fins, their total length varies from 8'9" to 11'6". Now for the SD, or armor-piercing type. Fritz weighs 1,400 kilos and Esau 1,000 kilos. Both are beautifully streamlined, are painted light blue, and have light blue alloy fins. But of course, these bombs have no Kopf ring. These are the 500 kilo armor-piercing bombs. See the excellent streamlining of the one on the left. On the right is the 250 kilo, an unusually short one and probably meant mainly for attacks on shipping. It has a dummy tail extension formed in one piece with the fins, which gives it better ballistics. This idea of a tail extension is applied to one of the 50 kilo SD bombs. The two types of 50 kilo armor-piercing bomb look like this. Here is the combined tail fin and extension piece cast in light alloy. Well, that gives you an idea of the different types of German HE bombs which have so far been dropped in this country. Now let's apply this knowledge to the problems of bomb reconnaissance. Here's a nice hole found after a raid. It's about the size of an ordinary saucer, 6 inches across. So what's the answer? We know the 50 kilo is 8 inches in diameter, and so this hole is too small to have been made by a bomb at all. It's the entry hole of an unexploded AK shell. It must be reported, but it's not dangerous as long as it's in the ground, and no evacuation will be necessary. Here's a clean hole in the concrete roof of a 5-story factory. It's about the size of a gramophone record, 10 inches across, which is the size of a hole made by a 50 kilo bomb. From below, we see that the bomb has cut right through a steel girder. That means it's armor-piercing. It's gone through the 5th floor, leaving a normal 10-inch hole. Done the same on the next 2 floors, and then come through the hole you see here, striking a pipe with its fin. This has turned it sideways so that it's gone through the 1st floor on its side and has left a complete silhouette cutout of its shape. The bomb has finally broken through the ground floor and buried itself in the earth. The fins, which must have been broken in flight, have followed the bomb into the hole, and pieces are found by this police inspector who is first on the spot. It's interesting to see that the bomb after removal is not scored in any way, in spite of having sheared through the steel roof girder. And the answer is 50 kilo SD. The hole of entry of a bomb in loose earth, a round hole about the size of a gramophone record, it's not so well defined as the one in the concrete roof, but it's obviously a 50 kilo UXB. Here's an easy one, the crater of an exploded 50 kilo. 10 to 15 feet across and with raised edges. But what's this? At first glance it looks like another 50 kilo crater, but it's suspiciously shallow and straight-sided. Maybe it's the false crater made by a big unexploded bomb. So let's take a look round. Ah, here we are, a piece of Kopf ring. That means 1,000 kilo or over. If a 1,000 kilo bomb had gone off, it would have left an enormous crater like the one you see here. So we can be pretty sure from finding the piece of Kopf ring in the crater that a big unexploded bomb has landed. If we probe carefully, we shall probably find the track of the bomb. Ah, here it is. And now, what's this? It's such a shallow crater that it might well be the hole of entry of a large UXB. but the score marks in the grass radiating out from the crater show that an explosion has taken place. If you probe this crater, you'd find no soft spots. A small bomb has exploded instantaneously. Here's an interesting hole. Although it was reported as an unexploded bomb, it was not made by a bomb at all, but by a hard lump of yellow clay on the left of the hole there. This is a similar hole, but the lump of clay has bounced out. High-flung debris such as masonry, rocks and concrete will make a hole when it comes down. Now here's a more difficult one. There's a great deal of damage and debris in this room, but the wall behind it shows no trace of splinter marks. So here again we may have a UXB. Then the light bulb and the mirror on the wall would have been cracked by blast if a bomb had gone off. You can't see the hole of entry, but you should certainly report it as a UXB, say a 250. This is the hole of entry of a 250 kilo unexploded bomb in a street. It's about 16 inches across, the size of the steering wheel of a normal car. The hole of entry of a 500 kilo bomb is a bit larger, about 20 inches across, the size of the wheel of a private car without its tire. Here's another case of a UXB which penetrated a house. It's difficult to tell the size as the hole of entry is blocked with rubble, but in all probability it's another 250 kilo. This too is an obvious case of an unexploded bomb, probably a 250 kilo. The size is difficult to gauge accurately owing to the fact that it's fallen through wooden floors. It's left no clearly marked hole, but has torn off complete planks. This is a typical example of the damage done by a 250 kilo bomb which has exploded inside a house. And this is the sort of crater it makes when it explodes in open ground. Notice particularly that the chimney is still intact, although the blast has shattered all the tiles on the roof. Blast will usually leave chimneys intact. It's earth shock that breaks them. At first sight, the amount of damage here and the size of the crater suggest the bomb has gone off. But if you take your mind away from the damage and the crater itself and take a look at the ground around, you'll notice a suspicious-looking crack, which suggests earth movement due to the deep penetration of a 250 kilo or larger UXB. And when we look up at the wall behind, we find no traces of blast or splinter, but another telltale crack, typical evidence of earth movement. With a very heavy UXB or one falling nearer the house, it is possible that the chimney also would have been broken by the earth movement. Now, what's this? There's no crater, and no trace of blast or splinter, but the whole surface of the road has been heaved up. If a bomb penetrates a sufficient distance below the ground before it goes off, the explosion may be completely contained below ground. This is what's known as a camouflage. Although this case is obvious, frequently the surface indications are so slight that you'd be quite correct in reporting it an unexploded bomb. The carbon monoxide in the cavity of a camouflage is deadly poison. The surface may cave in if walked on, and should therefore be roped off. Ordinary service or civilian respirators are quite useless against carbon monoxide, and it's impossible to rescue anyone who falls into a gas-filled camouflage. Here's the sort of thing you should be on the lookout for when you're making a bomb reconnaissance. The broken branches here show the path of this particular bomb. Here are the remains of an oil bomb which has failed to ignite. This bomb contains a very small burster charge, just sufficient to split the thin case and scatter the oil. See the oil all over the ground and up the lamppost there. So much for the detection of unexploded bombs. And now you'll want to know, will it go off by itself? Or will anything set it off? The answer is in the fuse. Here is a section through a 50 kilo bomb which enables us to see the general fusing and exploder system employed in all sizes of German bombs of 50 kilos and over. The fuse is located in the side. The fuse itself fires an initiator known as the gain. Fuse, gain. The gain is a small cartridge of extremely powerful and highly sensitive explosive. The gain is surrounded by this ring picric pellet, and below this are one or more solid picric pellets, depending on the size and type of the bomb. These, in turn, are surrounded by the main explosive of the bomb, TNT, or whatever alternative is used. The explosive, therefore, is actually built up in three main stages. gain, Pickrick's main charge. Here's a bomb which has been emptied of its main charge and simply contains a fuse pocket, which alone holds enough explosive to be really dangerous. This fuse pocket is now to be detonated by means of a small gun-cotton primer. You will see that the fuse pocket alone has been sufficiently powerful to do quite a lot of damage to the timbering of the hull, and has turned the bomb completely upside down, splitting it from end to end. It has split at the weakest point, the weld. A fuse pocket, therefore, is a dangerous thing, and if you find one by itself after a raid, as may happen if a bomb breaks up on landing, you should surround it with a sandbag wall, so that if it detonates, it won't do any harm. As we shall see later, it may contain a delay action or anti-handling fuse. All German fuses in bombs of 50 kilos and over are of the electric type and work on the same principle. In the fuse cap are two plungers. As the bomb leaves the plane, a condenser is charged through one of these plungers. While the bomb is in the air, this charge leaks through a resistance to the firing condenser. As the bomb strikes the ground, a sensitive spring is vibrated in the cup, and this makes the contact, firing a percussion cap which fires the gain. If the other plunger is used for charging, then the same sequence of events takes place, with the additional short delay of a slow-burning fuse before the gain is fired. Broadly speaking, German fuses are divided into three classes. The first is the impact fuse, which is designed to detonate the bomb either instantaneously or through a slow-burning fuse, which gives a small delay up to 15 seconds. The second type is the delay action. It consists of a fuse similar to the impact fuse, except that it fires a mechanism which starts a clock, and it is this clock which in turn fires the gain. The clock may be set to operate at any time up to 80 hours after landing. Sometimes the clock starts and then jams for some reason. It may then be in a highly sensitive condition, needing only a slight jar or vibration to restart it, and possibly detonate the bomb in a matter of seconds or as much as half an hour or more. Although this fuse could be used in any sort of bomb, its use at present has been almost entirely confined to the 250 and 500 kilo types. Next we have a booby trap, the Zeus 40. Should the fuse be withdrawn, the booby trap detonates the bomb by means of this striker, which you can see move across the bottom. The striker fires a percussion cap, which explodes the gain. The booby trap is inserted in the fuse pocket in this manner, between the pickricks and the main fuse, the gain of which holds back the mechanical striker. Here's a fuse pocket containing a delay action fuse with its clock and gain. Here is the striker of the booby trap, which is held back by the gain and is prevented from being forced by this spring to detonate the cap. The cap, through this flash path, explodes the gain of the booby trap and detonates the bomb. Now watch what happens when the main fuse is withdrawn. Let's take a closer look and do it again. This is the anti-handling fuse. It is similar in design and appearance to the ordinary impact fuse, but the charge does not leak through to the firing condenser until after the bomb has landed. Then, any vibration will complete the circuit through the sensitive spring contact and detonate the bomb. In this case, we have had the fuse specially wired up so that any vibration which causes the firing contact to close will light a flash lamp and register current on the ammeter. By the way, this particular bomb shows the welded design of the SC type very clearly indeed. Now you'll notice that the slightest vibration is sufficient to make the flash lamp light up, and would therefore detonate any bomb fitted with this fuse. Moral: don't allow vibration from heavy traffic or any other source near a UXB. As a further complication, If either of the plungers is depressed to the smallest extent, it will detonate the bomb. Watch the ammeter closely, and you'll see that an appreciable current flows every time the plunger is depressed. Moral again, don't meddle with fuses. Bombs, whether designed to go off on impact or not, will normally penetrate to a considerable depth. About 10% of all bombs fail to go off. Some of these are genuine delay action bombs with or without anti-handling fuses. Others are duds. It's impossible to establish which until the bomb is exposed. Therefore, all UXBs must be treated as potentially dangerous. These houses are threatened by an unexploded bomb in the green. The following safety precautions should at once be taken. All buildings within 30 yards of the bomb should be cleared. The outer doors of the evacuated buildings should be left wide open, and all windows within 100 yards of the bomb should be opened wide to prevent destruction of glass and consequent injury to people from flying glass splinters. No heavy-wheeled traffic should be allowed within 50 yards of the bomb. Roads and approaches within that distance should be closed to heavy traffic. Pedestrian traffic should be confined to the occupants of unevacuated houses. And even in such cases, they should be advised wherever possible to enter on the side remote from the bomb. When an unexploded bomb falls in a straight street, all buildings within a radius of 30 yards should be completely evacuated. From this 30 yards, all rooms on the side facing the bomb must be cleared, up to 100 yards along the street. But occupants may remain in rooms on the second or higher floors on the side remote from the bomb. The street must be barricaded, usually at a convenient diversion, but certainly not less than 50 yards away. When a bomb falls in a small court or alley, all buildings should be cleared entirely up to 30 yards from the bomb. Buildings which are not shielded, for instance, buildings opposite the opening of this alleyway, should also be cleared. In a dive bombing or low-level attack, bombs may sometimes come to rest uncovered on a hard surface or penetrate only slightly below ground level. These are known as unburied bombs. For the purpose of what follows, an unburied bomb means one which is either on the surface or buried not more than 2 feet underground in the case of a 50-kilo bomb, in the case of a 250-kilo 4 feet, and in the case of a 500-kilo 6 feet. An unburied bomb, exploding, will cause blast and splinter damage over a much wider area than a buried one. And so the rule is to barricade a straight street 300 yards away from the bomb and to increase evacuation proportionately for unshielded buildings. Unexploded bombs may fall in places where their explosion would cause great damage to important installations, such as these. A UXB in or near some of these might vitally affect a major phase of the war effort, in which case the placing of the bomb in Category A would be authorized by the Regional Commissioner. This means that work on extraction will begin at once, regardless of the risk to life involved in working over the bomb during the known danger period for delay action fuses, the first 96 hours. Other bombs will be placed in Categories B, C, and D, and work will begin on them after 96 hours in order of their importance. Where bombs cannot be dealt with at once by bomb disposal units, there are, in certain cases, precautions which can be taken immediately the bomb has been located, in order to minimize the damage should explosion take place. For instance, this fellow has penetrated close to an important water main. Here is the bomb with its fins in the hole of entry. This is the water main. If the bomb explodes, the crater will extend roughly as far as here. Earth shock will travel along this path and probably fracture the water main. The water main may be protected by digging a trench close beside it, a little deeper than it, and outside the radius of the possible crater. The earth shock will be stopped by this trench from traveling onto the water main and damaging it. This method can also be used to protect the foundations of a building. This UXB is lying close to a factory. You can protect the factory from blast and splinter damage by building a sandbag wall between the bomb and the factory. This is the probable limit of the crater if it explodes. The sandbag wall should be built here, just outside the probable crater. It should be at least 10 foot high and at least 2 foot 6 inches wide at the top. The side of the wall furthest from the bomb should be sloped at an angle of 1 in 6. This bomb threatens by earth shock the foundations of the factory near which it's fallen and the valuable machinery in the basement. Considerable protection can be provided by packing the basement with sandbags on the inside so as to buttress the foot of the wall and absorb some of the earth shock. In addition to UXBs, you may find unexploded parachute mines. There are two kinds, type C and D. The principal difference between them is in their length. D-type being 5 foot 8 inches long without the rear cap, whereas C-type is 8 foot 8 inches. Both have an approximate diameter of 26 inches, both have a thin aluminium alloy case painted dark green, and both are designed to be lowered by parachute. The parachute cords are secured to this ring bolt, and the parachute itself is folded and packed into this compartment, which is closed by a bowl-shaped end cap. The cap is held in position by a catch against these spring-loaded plungers. When released, this end cap forms a pilot parachute which pulls the main parachute out of its compartment. The release catch is controlled by a wire attached to the plane. When the mine is launched, the wire is pulled and off springs the end cap. There are two other wires from the mine to the plane, one of which releases a safety pin from the fuse. So if you find any wire attached to a mine, on no account pull it. If the mine has failed to detonate, the fuse is probably in a highly sensitive condition, and the mine must on no account be moved or disturbed. A pull on the third wire arms the primer in this primer pocket, which is part of the exploder system designed to come into operation if the mine is submerged in water. When an unexploded parachute mine is reported, all buildings within 400 yards should be evacuated. And all traffic stopped within the same area. In the remaining houses up to 800 yards from the mine, occupants should keep clear of glass. Doors and windows should be kept wide open up to 800 yards. However, the minimum safety distance of 400 yards may be reduced to 300 if the mine is masked by strong steel-framed concrete buildings. This is the small German anti-personnel bomb. On release, the case springs open and forms a propeller, which rotates and arms the fuse. These bombs may be highly sensitive when found. They should be reported immediately and roped off to await the arrival of BD personnel. Other German weapons you may come across include incendiary bombs. The standard German incendiary bomb is the 1 kilo, which may be dropped with or without an exploder. It consists of a magnesium body with a pressed steel fin and a screwed nosepiece containing the fuse. In action, the fuse ignites a priming composition which burns with great heat, consuming its own oxygen and finally igniting the magnesium casing. The fuse works this way. The shock of landing causes a pellet to carry forward the percussion cap onto the striker pin fixed in the nose cap. The strong spring, which must be overcome by the pellet, is an additional safety device. Watch what happens when it strikes the ground. Here's a section of a real bomb showing the fuse, and here's the diagram again. When an exploder is fitted, it goes in here and replaces the screwed cap in the tail. Its charge is sufficient to spread burning magnesium fragments over a wide area. Explosive incendiary bombs have so far been marked by a red letter A on the base. Otherwise, they look exactly the same. The exploder is hidden in the tail and will detonate by heat within 2 minutes of the bomb first firing. All incendiary bombs found by ARP personnel should be handed to the police, who will in turn arrange to pass them over to bomb disposal units for attention. This is an incendiary bomb container. The two side pieces are hinged together at the top, and when the lid flies off, they open outwards to release the 36 incendiary bombs which it holds. The lid is often found by itself after a raid. It is released by one of these two electrical devices, which are charged as the container leaves the plane and timed to operate a few moments later. This is what's left of a Molotov pantry, a large container for incendiary bombs. It's 10 foot long and holds 700 incendiaries, which are released through trapdoors operated electrically. A flash bomb used for night photography, very like the 50-kilo SC bomb, but filled with magnesium powder and painted either aluminium or yellow. Another thing you may find is a German flare casing, or one of its parts, an object rather like an aluminium saucepan. This is normally located in the container, where it is held in place by the fuse, passing through these holes. The container holds the parachute. It also holds the flare candles, which when released hang from these parachute cords. The candles may be from 1 to 4 in number, and as well as the supporting wires, you may find cords like these. Be careful not to pull them, as they may fire a burster charge and cause serious casualties. You may find unexploded AK shells on or near the surface. They should be left alone and reported as for unexploded bombs. But no evacuation will be necessary. Here are typical examples of AK shells after firing. These are typical cannon shells, which may also be found after an aerial battle. Here you see the size of a cannon shell. The firing mechanism situated in the nose is extremely sensitive. For this reason, aeroplane cannon shells must be handled with great care, as they may explode if dropped or even jolted. In no circumstances must the pointed end be touched. The shell should be picked up by the middle, and great care should be taken to keep it horizontal, to avoid jolting or sudden change of direction, and above all, to avoid dropping it. If you have to carry it far, it should be placed in a basket or box, lined with soft material. If you find several shells, don't carry more than 2 in any one box, and see that these are separated by a wad of soft material. If you find a board like this, with or without a small rubber balloon and a length of cord attached to it, there may be in the neighborhood a small yellow UXB. This is very dangerous and highly sensitive. The slightest pressure on this ring in any direction will detonate the bomb. It may be found with several hundred feet of piano wire attached. When found, the bomb must not be moved, but the piano wire may be cut with pliers. Although demonstrated at close range here, this wire should in fact be cut not less than 50 feet away from the bomb. A sandbag wall should then be built to mask the bomb until BD personnel can destroy it. So much for what to look for after the event. Today, factories are working, turning out the implements of war. People travel to and from their war work, with all the speed and comfort that our modern transport system can provide. The army trains to defend our countryside against the invader. But across the Channel, the Luftwaffe prepares for yet another raid. Here are Dorniers being loaded up with 50-kilo bombs. And over here are 500 kilos, shortly to be dropped upon an English town. Perhaps your town. So on into the night, the whistle and crash of bombs falls on our wakeful ear. Ack thunders into the flame-torn sky. Night fighters split defiance overhead. And then comes morning. And whether or not this raid can be judged an unqualified success is now in great measure up to you. Bombs causing idle factories. Bombs closing utility services. Bombs paralyzing railways. Bombs blocking streets and thoroughfares. Bombs interrupting communications. And all these bombs are UXBs, harming the war effort far more than their brothers which went off with a roar in the night, whose destructive efforts are even now being made good. And the unexploded bomb is a job you have to deal with. It is the business of the civil defense and the armed forces to be organized to reduce the nuisance value of UXBs to a minimum. To avoid any confusion or duplication of records, all reports of UXBs, whether by the public, armed forces, warden service or police, go through regular channels which ensure that the bomb is properly recorded and made safe with the least possible delay. The attention paid to it depends on its importance, firstly to the war effort and secondly to the public safety. As UXBs must be dealt with in a proper sequence of priority, all reports are filtered through regional headquarters before action is taken. Here is how the machinery works in chart form. A member of the public reports a suspicious hole. Perhaps he goes to the warden's post. As well as setting the bomb disposal force in motion, contact is also made with the police, so that they can exercise their function of maintaining order and public safety. Or supposing John Citizen sees a policeman before a warden, the machinery still functions smoothly. These are the normal routes, but flexibility is the keynote of the organization. And provided that continuous collaboration exists between all units in and out of raid periods, then the organization will not only exist, but live and do a good job. The latest unexploded bomb report, which is in 4 parts, covers the birth, life and death of a UXB, and later forms its permanent record. Part 1 must be completed by the man actually making the reconnaissance, who should be the bomb reconnaissance warden. Whether or no the bomb is dealt with promptly and efficiently will depend largely on the accuracy and careful judgment of his report. Point 6 means that you must keep any part you find which may help in identifying the bomb, and that you must tell the BD officer where he can get hold of it quickly. The nearest warden's post is probably the best place. The suggested bomb category is filled in by the group or county controller after careful consideration. And in Part 2, the regional commissioner will actually allocate the final priority category. Part 4 is the last act, where the clearance certificate is torn off and handed over by the bomb disposal section to the appropriate warden's post, as soon as the bomb has been removed or made safe. Now let's see what happens in practice during and after an actual raid.
Said it was this size. I said, yeah, that's not a matter, that's a pumpkin, and you look out it don't turn into a coach. Hello? That's a UXB. Sounds as if it's over by the Odeon. Get control and ask them to send Smith down. I'm going to have a look.
Is that control? W4. Mr. Williams has gone to look for UXB over by the Odeon. He said, would you send Mr. Smith down, please?
Is that you, Smithy?
Yes.
Blimey, you've been quick. Well, it's a UXB, all right. Look.
250 Finn. Right, I'll warn the people in West Street to be ready to evacuate while you nip back to your post and ring control.
All right.
And so he rings control. And the report of one unexploded bomb has reached the local report centre.
Control. Nil. Area damage. Name of roads blocked. Number road between Redriff 1 here and Main Rose Street.
Don't like the sound of it. Better send the bomb reconnaissance warden down to make a thorough investigation.
Call that was there then.
Headquarters.
Regional telephone exchange makes the connection, and the report comes through to the regional message room. And so, within a very short while, regional control knows that an unexploded bomb, believed to be 250 kilos, has been found in the Odeon car park, West Street. And although this preliminary report has been telephoned through to save time, Smith, the bomb reconnaissance warden, has already made out his full report on part 1 of the form. 2 unexploded bombs fall in the local barracks. Even when a UXB falls in barracks, or on any military property, it must be reported immediately to the local Civil Defence Control Centre, who will grade its importance. Only then will the BD force take action. The sentry who finds them reports at once to the guardroom. This barracks has its proper officer and NCO trained in bomb reconnaissance, who inspect and report on suspicious holes. The first bomb on the parade ground is not of vital importance, but the other has fallen near the magazine. On being advised of this, the local Civil Defence Report Centre asks for and gets a high priority. Then comes the dawn and the all clear. Wardens begin to make their rounds, and one of them finds an obvious UXB hole in the road near an important factory. Within a few minutes, he has telephoned his report through to his local report centre. They immediately relay it to the various essential services and to local police headquarters. The report has also, of course, been forwarded to regional headquarters. The warden who first discovered the hole, together with a police inspector and the bomb reconnaissance warden, have already gone down there to make out the full report, decide on the precautions to be taken, and which houses are to be evacuated. In the meantime, the post office engineers have found out that the bomb is a threat to important trunk cables, which run under the road at that point, and they get on the telephone to the group controller, with the result that the regional operations chief receives a message which he takes to the senior bomb disposal officer. The BD officer phones the local BD headquarters and tells them to make a special reconnaissance of this bomb. Meanwhile, the police close the streets and divert traffic. The factory is closed down, and the employees are sent home. The houses in the danger area around the bomb are evacuated. The bomb disposal reconnaissance officer arrives on the scene and takes a look at the hole. The clean hole of entry is quite obviously that of a 250 UXB. He wastes no time, but notes its exact location and the equipment likely to be required for its removal, so that he can get back as quickly as possible to send in his report to regional headquarters. There, shortly afterwards, a conference takes place between the regional operations chief, the senior bomb disposal officer, and a post office official, who manages to convince them that the threatened cables are important enough to warrant the bomb being placed in Category A. That is, if the regional commissioner will sanction it. Promptly, the order goes out from regional headquarters, and a bomb disposal section is soon on the site. The men start unloading their gear at the road barrier, while the section officer takes his sergeant to give him his working instructions. Within 48 hours, the bomb is made safe and removed from its hole. The section officer hands the warden his clearance certificate, and the bomb disposal lorry goes off with its load. The post office cables are safe. The streets are reopened. The factory is working again, and very little time has been lost. And the morale of the people who live down that street is as high as ever, because so short a time has elapsed before their return home. Another falls in the back garden of a private house. Warden Harvey, who's in a hurry, takes a look at it. The hole seems to him much too small to be the crater of an exploded bomb. All the bombs he's seen have penetrated deeply and left largish craters. Remembering something of what he's learnt, he jumps to the conclusion that this is the entry of a really large UXB. So off he goes to report it. But if he had only taken a couple of paces forward and looked round at the house, he would have seen enough blast damage to prove conclusively that this was a small bomb which had gone off. Anyhow, he didn't, so the police and wardens wasted a great deal of valuable time in closing the street, thereby disturbing the traffic, and in evacuating a lot of people unnecessarily, thereby endangering the morale of these people. And all because Warden Harvey didn't make a thorough reconnaissance. Not far away, old Joe, who has helped in every raid and has a nose for UXBs, sees a suspicious hole and ambles off to tell his warden about it. It's very close to the gasworks. The warden, who's extremely busy, is only too glad of Joe's help. Joe has a knack of being right, so the warden makes a note of what he says. Without going to look at the hole himself, he later sends in a report. This results in the gasworks being closed down, and all the local inhabitants who aren't evacuated are unable to cook their dinners. When the bomb disposal reconnaissance officer arrives, he points out to the warden the various signs of blast and splinter. The bomb had gone off, but the warden had made no personal reconnaissance. A whole street had been evacuated unnecessarily, and thousands of families had had to do without gas. Finally, there's the bomb which dropped on the railway line, and is found by one of the shunters. It's near an important munition factory, too. Now, this bomb has fallen in a marshalling yard, and nearby several important main lines converge into a bottleneck over a bridge. The shunter makes his preliminary report at once, of course. As a result, streets are closed. The factory is shut down. Houses are evacuated. Traffic on the railway comes to a standstill. The railway company have applied through the local authority for a Category A, and so a senior bomb disposal officer meets the railway's divisional engineer and traffic superintendent at the bomb hole for a conference. It is an obvious unexploded bomb, but rather than accept Category A and risk lives unnecessarily, the BD officer shows how, by careful screening, the hazard may be reduced, limited traffic resumed, and the munitions factory reopened. The railway officials quickly appreciate this and agree to the proposal. 8 loaded coal trucks are shunted in on either side of the bomb hole, but sufficiently far from it to be on the lip of the probable crater should the bomb explode. Meanwhile, the train, waiting in the distance, is expecting the signal to proceed. With the coal trucks positioned in this way, the lines on the outside of the trucks are effectively screened. The railway can now be reopened to traffic, as long as trains come slowly past the bomb, in order to reduce vibration. And the factory opens once more, with a minimum loss of production time. Any one of you may have to tackle a UXB. And don't think that an unexploded bomb is a rare thing. In one London district alone, 88 unexploded bombs fell in one single night. Speed is essential. An unexploded bomb is a menace right up to the time it is rendered safe. But speed is useless without method. Accurate reconnaissance is the first vital step. Then results of that reconnaissance should be clearly and fully set out on the proper form. That puts the whole organization in motion. First, the application for priority. Then the allocation of category, which gives the bomb its correct place in the BD unit's time schedule. After that, the bomb disposal section can get down to the job. When the clearance certificate is torn off the report and handed to the warden, the unexploded bomb is no longer a threat to Britain's war effort. Its obituary notice has been written, and yet another enemy bomb goes quietly on its way to the cemetery. UXB, the instrument of calculated destruction, the menace from the night sky, the pride of Göring's Luftwaffe. Yet in the cold light of day, Hermann is dragged away towards his ignominious end.